Baeyer Villiger Oxidation. Oxidation of ketones to esters by treatment with paracids is Baeyer Villiger oxidation. What are paracids? Paracids are compounds which contain one more oxygen atom than carboxylic acid. Means if I take CH3COOH, this is acetic acid. If there is one more oxygen, here there is peroxy linkage. So this is per-acetic acid. Similarly, if you take this compound, this is per-benzoic acid. And if you take this compound, this is metachloro perbenzoic acid. Similarly, CF3COOH. All these are some paracids which we generally use in Baeyer Villiger oxidation. So what happens in Baeyer Villiger oxidation? Ketone, when treated with any of these paracids, will get converted to ester. So what is happening here? There is insertion of oxygen between the carbonyl carbon and alpha carnatum. So there is insertion of oxygen between the carbonyl carbon and alpha carnatum. So what will I get here? I will get an ester. So if you look at the mechanism of the reaction. So mechanism of the reaction, how will we learn? I will start with a ketone and treat with peracid. So the carbonyl oxygen gets protonated. So what will I get? Carbonyl oxygen gets protonated and the carbonyl carbon will get positive charge. Now the percarboxylate ion attacks the positively charged carbonyl carbon, resulting in the formation of a tetrahedral unstable intermediate. So what will I get here? RCOHR OO C double bond O CH3. Means I'll get a unstable tetrahedral intermediate in which the peroxy bond, the oxygen-oxygen bond is very weak. So this undergoes heterolytic cleavage. When this oxygen is undergoing heterolytic cleavage, one of the R group from the ketone will migrate towards that oxygen. One of the R group will migrate towards oxygen. So what will I get here? RCOH O R plus CH3COO minus. So this is protonated ester and carboxylate ion will get. The protonated ester loses a proton. So if this proton is lost, what will I get? RC double bond OR plus CH3COOH. Means what will I get? An ester I am getting here. We are getting ester. So again I am repeating. Ketone is treated with peracid. So the proton of the peracid will attack the carbonyl oxygen. So you will get a positively charged carbonyl carbon. This percarboxylate ion now attacks the positively charged carbonyl carbon, resulting in the formation of a unstable tetrahedral intermediate. Unstable tetrahedral intermediate. So the oxygen-oxygen bond of this intermediate is highly unstable or weak. The oxygen-oxygen bond is weak. So it undergoes heterolytic cleavage. So if it undergoes heterolytic cleavage, one of the alkyl group of ketone will migrate towards oxygen. One of the R group of ketone will migrate towards oxygen, resulting in the formation of a protonated ester and carboxylate ion. The protonated ester loses proton to form ester and carboxylic acid. So this is Baeyer Villiger oxidation. So if you see, alkyl group is migrating towards oxygen here. So now we have to learn about migrating tendency of the alkyl group. Migrating tendency of the group. So if you see the migrating tendency, if the ketone is unsymmetric, a better electron releasing group will migrate during the rearrangement. If the ketone is unsymmetric, a better electron releasing group will migrate during rearrangement. So what is the order now? Tertiary greater than secondary greater than primary. If the ketone is a dialkyl ketone, the migrating tendency will be more for a group which is more electron releasing. So tertiary, migrating tendency of tertiary alkyl group will be more than secondary, more than primary. If it is unsymmetric dialkyl ketone. But if the ketone is unsymmetric aryl-alkyl ketone, aryl-alkyl ketone. If it is aryl-alkyl ketone, aryl group will have more migrating capacity than alkyl group. Okay. Then if it is diaryl ketone, in diaryl ketones, the migrating tendency in aryl group will be facilitated by electron releasing group in para position. So aryl group with electron releasing group in para position migrates more readily than other groups. So if I take OCH3C6H4, OCH3 is electron releasing group. If it is present in para position, then the migrating tendency of that group, phenyl group, will be more than CH3 C6H4, which will be more than phenyl. Phenyl will generally more than tertiary, secondary, primary and methyl. Again I am repeating, if you look at the mechanism, one of the alkyl group in ketone will migrate towards oxygen. So if there are two different alkyl groups, means if the ketone is an unsymmetric dialkyl ketone, then the migrating tendency of alkyl group will be more if it is more electron releasing. So tertiary is greater than secondary greater than primary. If it is an aryl alkyl ketone, migrating tendency of aryl group will be more than alkyl group. If it is diaryl ketone, and if the aryl group is having electron releasing group in the para position, that group will have more migrating tendency. So the electron releasing group in the para position facilitates the migrating tendency of the aryl group. So this is the order of migrating capacity of different R groups there. So what is Baeyer Villiger oxidation? Oxidation of ketones to esters in the presence of para acids is Baeyer Villiger oxidation.